So thank you everyone for joining us tonight. We have Ed from ARM and we have Paul from AWS. They can be speaking about AWS IoT and how to get started without any hardware. I'm really excited about this topic. Ed, you can take it away for us.
Great, thanks, Ryan. Thank you all for joining. I appreciate the opportunity to come here and talk with you. As Ryan said, I'm Ed Miller. I'm a senior principal engineer at ARM. I've been with ARM for about 3 years, leading technical engagements with strategic partners like Amazon. So my main job these days is relationships with our technical partners. But my background is in engineering. I actually started as a hardware engineer, developing ASICs for a number of different applications and startups in the California Silicon Valley. I've done software drivers and low-level work, and I've also led full product development for IoT products, machine learning products, and multimedia products, all the way from the embedded software up through cloud services and mobile applications. So I've got a little experience across a few different things. I also volunteer in my spare time, which is few and precious hours, with a project called the Bear ID Project, which I started with a couple of colleagues. And we're developing machine learning solutions to non-invasively identify wildlife for wildlife monitoring and research. My main focus, as you can tell by the title right now, is on bears, mainly brown bears. So identifying individuals, so researchers can help track them, and we hope one day to make an IoT solution out of that, so we could actually identify bears in real time in the wild. So what are we going to cover here today? I'm going to give a quick overview of ARM and IoT in case some of you may not be so familiar with the topic. Talk a little bit about what some of the challenges are around IoT, and then talk about some of our ARM solutions for helping with those problems. So ARM virtual hardware is the main thing I'll talk about. I'll talk a bit about an example application that I'll be showing you. Then I'm going to hand off to Paul for talk about the AWS IoT software and services that they provide, and then I'm going to end up with a demo before we have a little bit of Q&A. So ARM, for those of you that don't know, we design and license compute technology. So we design processors, graphics processors, neural network processors. We license them to a vast ecosystem of silicon partners who actually make the chips and sell them in many different types of applications. And we think that ARM processor technology touches at least 70% of the world's population today. And we provide these applications across different markets, client, which is basically anything with a screen from our standpoint. So we're basically in almost every smartphone in the world today, an ARM processor with somebody else's silicon manufacturing. In IoT space, we're in many consumer devices, a lot of rich embedded devices that might be used in industrial applications, or for those of you familiar with the Raspberry Pi, that's based on ARM processors as well. And a lot of wearable technologies make use of our ARM compute technology. We're in a lot of automotive applications, and then also in infrastructure. And for AWS, you may be familiar with their Graviton instances. Those are also built on ARM processor technology. So IoT, I'm sure many of you know, just trying to simplify things here a little bit. It's about physical objects that can sense or process or act on the environment using a software, and they're connected over the internet. So they are things talking to each other over the internet, oftentimes talking to the cloud or through the cloud. So an example of some common IoT usage for home today is something like the Amazon Echo product where you can ask Alexa to turn on your light. The Alexa speaks to the Alexa voice service cloud. That cloud determines that you want to turn on a specific light, and it talks to that device service cloud, and that device service cloud sends a message down to the light to turn on or off. And you can also get status information back and things like that. So this is the basic flow of what IoT is about. And there's industrial applications and home applications and many different markets that IoT is being used for these days. And there's a vision that IoT was going to take over every kind of device, and every kind of device was going to be sending information up to the cloud and helping you make things more efficient and learn better processes and all that kinds of things. But it hasn't quite taken off as fast as most people were predicting. And why is that? Well, one of the reasons is all these kinds of hardware are hard. Scalability is very challenging. You know, every device that you work with is a little bit different, and it takes some effort to get your software working on all these different devices, and creating the infrastructure around all these different kind of devices can also be very challenging. And it's also hard for developers to develop, because you need basically a physical board for every type of device that you're trying to support. You end up creating what they call board farms, which is, you know, lots of IoT devices connected to your network that you're trying to update and test and simulate on, and it gets very complicated. Engineering costs are very high to maintain, and there's also limited ability to actually interact with those boards. You have to build very complex infrastructure to understand, did the light come on, did, you know, the motor do what I want it to do, and how can I give it input automatically and try to automate all these tests. It gets very challenging. And last but not least, it's just not available in public clouds. And that's a real limiter today, because a lot of developers are working in the cloud. So at ARM, we've had a technology for simulating our processors for many, many years, and we provide these to our silicon partners while they're building their development. And these virtual hardware, as we talk about them, are essentially functionally accurate representations of a physical chip, or in some cases a physical board. So it's basically simulating the software visible behavior. So you can, it's essentially, we think of it like a virtual machine, the IoT equivalent of a virtual machine. So you can actually run your software on these virtual platforms and do what you would try to do in the real world. And for cloud developers, this is a lot more straightforward, because it runs as an application in a Linux environment. So it can very easily be scaled in the cloud. It removes dependency on the hardware availability. And it's very easy to integrate with test flows and operational flows that you might be familiar with in the cloud already. So the first version of ARM virtual hardware that we've released into the market for developers, it's built into an Amazon machine image. It's available on the marketplace. It runs on standard EC2 instances. It's based around Ubuntu 2004 LTS, so things that you're very familiar with. In terms of what is it simulating, it simulates our latest Cortex M55 processor. So this is a microcontroller that we introduced last year and is starting to be shipped in chips starting this year. This is our latest microcontroller, which has some very strong properties around digital signal processing and just easy to program. It has a lot of security capabilities in it. We also have a micro NPU, which is a neural processing unit. So that's basically a co-processor that accelerates smaller machine learning models that you might want to enable on the edge. So that's also in this virtual hardware target. And it has, a memory subsystem, SRAM, DRAM, or flash as necessary. And it also has a simulation of a number of the peripherals, programmable IOs, the serial interfaces, and most importantly, Ethernet. Otherwise, this whole Internet of Things couldn't happen if you can't connect to the internet. And this virtual hardware AMI also has all the tools that you need to support your development, to build the applications, and so it's pretty much a self-contained unit that you can grab a code repository, build it, run it, get results, all in a cloud instance. So much more similar to what you'd be familiar with in cloud development. So the example application that I'm going to be talking about, that I'll be demoing towards the end of this discussion, it's part of what we call ARM Total Solution, and this particular one is a keyword detection. And the idea of ARM Total Solution is to make everything a little bit easier, to provide you with the baseline software so you can get up and running quickly. You don't have to worry about writing boot code or playing with registers and getting peripherals working. It's a full stack that just works out of the box, and then you can start to modify and augment to do whatever you need for your application. So we have this keyword detection example. So it uses pretty much everything that I described in the virtual hardware. I'll show you a quick example that's called Blinky, which is kind of the hello world of IoT, where you basically boot up a board and you get some LED flashing. And then I'm going to show you a little more complex example that is keyword detection or keyword spotting. And this uses a machine learning model to recognize your voice input. In this particular case, the model is trained to detect when a user says yes, no, up, down, on, off, and maybe about 10 different words. And you could then program it to do something specific on those word detections. And in our case, all we're doing is we're taking those word detections and we'll send them up to the AWS IoT cloud to record them there. And then once it's in the cloud, there's all number of AWS applications AWS services that you could utilize to further process that data and do various things. And I'm going to leave that for the later discussion. But so we'll walk through this application. I'll show you how it works, but the idea is, since this is all up in the cloud, you obviously don't have microphones, you're not talking directly to the board. So we have some virtualization of the interfaces. So like the serial interface that would normally be connected to a microphone, we basically have a Python script that you can use to stimulate these inputs to the chip. So in this case, we've got a Python script that reads a WAV file that has a short voice recording in it. It sends that into the chip. While that's being received as an audio stream, it's running this machine learning algorithm to detect keywords. When it detects keywords, it prints it out to the local terminal, but it also sends a message up to the IoT cloud. And that's pretty much how that goes. And when we get into the demos, you're welcome to ask me about anything there. And yeah, actually that's pretty much all I'm gonna cover for now. So let me hand off to learn a little bit more about AWS IoT. So take it over, Paul.
Okay, great. Let me get my slides prepared here.
And what is busy with that? So we'll do a Q&A at the end, and your entry for the lucky draw is a survey that I'm going to be sharing in that period that we're going to do the Q&A. And I'm going to just give away a bunch of AWS credits for a few lucky winners. We'll see how much. I still have a bunch of AWS credits, so I might give away quite a few.
Terrific.
Yes, then you can continue, Paul. Thanks. Sorry.
No problem. Great. So yeah, I wanted to just kind of follow on with some of the things that Ed talked about and tell you a little bit more about IoT as AWS sees it. And you know, my name is Paul Butler. I'm a global partner solutions architect and IoT specialty. And just a little bit more about me. I've been in the industry for, well, longer than I want to admit to, but a lot of years, and more than 30, more than 35. I guess I'll go that far. But I've been around as a software architect. You know, working mostly with the hardware developers, and that's why I was very interested in this particular topic, is because of all the years that I've worked, you have to wait until the hardware is developed before the software guys can actually start, you know, putting the RTOS and the bootloaders on the board. And if you're developing that low-level software, you're waiting. And by having those virtualization environments like this, you can actually start developing what we call shift left in your project schedule. Start developing a lot of your software before the hardware is even ready, you know, complete and ready to go into, you know, prototypes or production. And so, anyway, that's kind of the a little bit of background about me. Embedded software has been primarily my background. So, anyway, I just wanted to move on and talk a little bit about all the areas of technology that AWS has been building IoT solutions in. And you can kind of see just from the graph here that there's quite a bit of you know, breadth of types of applications that people have been working on, and we're really enjoying supporting the customers. You know, I work in the partner organization, so in the partner organization, we're working with partners like ARM, partners like the other silicon vendors that produce the parts, and but then getting down to working with the customers is the next step down from working with the partners that we help to kind of build out the equipment that they're going to need to build solutions. And so one of the ways that you know, AWS kind of looks at the I want to back up just a second here on this slide. If you kind of look at the bottom layer, this is the device software. It's not going to let me stay there, I guess. But let me try to back up one more time here. Yeah, at the bottom layer we have you know, the device software, and that's more or less what we'll be talking about today. But the next level up is the connectivity and control, and then we have the analytics, and that's mostly what we'll probably, you can kind of see here from this diagram. We also look at it as kind of a cycle where the device software provides new capabilities and features into the connectivity and control services, which then provides ability to do better analytics type services. And it just continues around because you continually increment and improve on those capabilities. So like, yeah, we'll focus more on the device software today. I assume that the audience is probably more cloud aware than they are the edge hardware domain. But but anyway, I wanted to talk about how the microcontrollers and the microprocessors that go into, we're making that distinction here where the low-level devices, which are sensors that can read data from the environment, whereas the microprocessors you might typically see as gateways running some, you know, Linux type operating system. Greengrass is also another one of the services that AWS offers, and it's edge software, but it runs on a Linux class device, and it is able to allow you to run, you know, even do some analytics or some aggregation of data, and things like that at the edge. Even extend some of your Lambda functions you can run out at the edge as well. So you can see from the diagram that you can actually connect your controller or sensor devices directly into the cloud, or you can aggregate them through a gateway and then send smaller amounts of data into the cloud. A lot of times you want to do that edge processing just to eliminate the need, and that's where the the AI and the ML applications are going to be able to filter out the amount of data that has to be sent upstream, so you don't have to do your ML applications at the cloud if you have the capabilities out at that edge. So that's what we want to talk about a little bit is, how can I build these edge devices to work with AWS? And so we'll start with talking about FreeRTOS. FreeRTOS, a real-time operating system FreeRTOS has been an open source project for many, many years. Lots of products out in the market are using FreeRTOS. You may or may not know that, but it is an MIT open source license, and it's free to download and free to develop into products that you're building. Amazon or AWS took over stewardship of the project simply because we wanted to continue to support it, add additional libraries to it. It is still an independent project, but we contribute heavily to a lot of the libraries that go into the support of FreeRTOS. And it has such a large support of different architectures, a lot of ecosystem support. So it's really a stable and mature real-time operating system. Some of the libraries that, starting with just your real-time operating system kernel, you still need, if you're going to use it in an IoT application, you've got to connect this to, you've got to connect to local things, which, or connecting into the cloud. You want to do security, and OTA stands for over-the-air updates. And so you still want to be able to update that device. If it's out in the field deployed and been running for a long time, and you discover that there's a bug fix that needs to go out, that's how you would do that. Here's a little more drill down into the kind of the libraries that are provided. Each of these libraries is an open source project of its own. You can go there, you can download the code off of GitHub, and you can use those libraries freely in your projects, and you can contribute bug fixes of your own if you find them. And certainly a pull request like that is great. A lot of these libraries are very generic. They don't even have a dependency on running on the FreeRTOS kernel. Some of these libraries, like the MQTT and HTTP, those will run even if you're not using FreeRTOS. You could use a different real-time operating system, and those libraries could still be ported into that environment. By AWS providing these libraries, though, it makes it really nice to know that you can build a device and you've got all of the interfaces that you need to complete your project. I don't want to drill down too much into what those libraries provide, but you can see, Wi-Fi, Bluetooth, cellular interfaces, and then in the cloud connectivity space, you're really talking about, the HTTPS, MQTT, and device shadow is a more or less, it's an AWS specific thing. If you don't know what device shadows is, that's about the ability to manage and maintain the state of a device, even if it loses, network connectivity, drops offline for a while, reboots, comes back online. The state of that device is maintained in a shadow environment in the cloud, and all it has to do is query its shadow environment and say, oh, okay, that's the state I was in before, I lost power or whatever, and it then can resume. On the flip side of that is, if somebody through a dashboard toggles a switch and wants to change the state of the device, then it's captured in the shadow, and when the device comes back on, it will immediately detect that and say, oh, okay, that's the new state we want to be in. Anyway, that's just a little bit more about device shadow, but all the connections through IoT Core, that's the channel to get to all the backend services in AWS as well. And you could, through a rules engine, you can distribute your data to various different services, databases, and whatever. Security. One of the things that we'll talk a little bit more about here later is PKCS 11. This is a way for taking advantage of security capabilities outside the processor itself by using secure elements. We'll talk about a little bit more about that in a minute. And then, as I mentioned previously, a little bit about over-the-air updates. The being able to make a change to your firmware image, being able to push that out to your device, make sure that it gets installed correctly without corruption, and then the device can then restart and be in a safe state. You don't have to worry that the device is going to be permanently offline because the update didn't go correctly. And then we also have for FreeRTOS this long-term support. So if you're using FreeRTOS in a device that you're developing, you have the confidence that even though there's a lot of new features maybe being added to some of the libraries or the kernel itself, if you're on a particular version of and you've deployed product, all you really want to concern yourself with at that point maybe is just applying a security update or a bug fix. But you don't necessarily, that device doesn't need some of the new features that have been developed. So you can stay on that branch of development for up to 2 years, and we'll continue to support the fixes for that. And Device Defender is another service that AWS provides. It allows you to kind of profile a device and say, here's what normal behavior of my device looks like. And if things start acting strange, if you're detecting anomalies, if suddenly your internet traffic is spiked up and you don't know why, that could be a potential compromise of your device. So by capturing this, it can monitor this, it can send out alerts and notify people that, hey, maybe a device has been compromised, and you can take it offline, or you can isolate it in another way, and then look into it before you put it back online, or maybe it does need an update. Okay, and then I wanted to talk a little bit about secure elements. Secure elements are another hardware device that are typically soldered onto your board next to the microcontroller, and they use what's there's a standards library called PKCS 11 that is an API interface to talk to these secure elements, but they provide this tamper-proof storage of cryptographic keys, and they also provide some other crypto functions that you can use for, but then your private keys and things like that are not exposed and not accessible. Only through this interface can you sign something, or you can validate something, but you never have access to the keys itself. And that's one of the purposes of these secure elements. And this is kind of a picture of what it looks like without a secure element. You typically would have to store your keys either in your user code on the flash or somewhere in your device. And if the device is physically accessible, well, that is a potential risk. People could tamper with it and maybe discover that. If you're using the secure element, then you have that secure element hardware off the microcontroller core, and then you have secure storage, and it's far less tamperable, I guess you could say. And so here I'll just talk briefly about, we have a device tester program. If you're in the business of building devices, we provide a device tester software it's an automated test suite that you can run through on your devices. And I think you can then download this software, you can run it on your device as you're doing your development and confirm that you're passing all the tests. And then there's a real benefit to that in the fact that once you've done that, you have the confidence, and it accelerates your testing. And then the key thing I wanted to mention here is it allows you to get listed. What does listing mean? Well, we have a device qualification program, and this qualification program It means that you submit your test results and prove that your device has been qualified. That allows you to be listed in our device catalog. And the device catalog is a place that people building, if you're just building solutions and you want to know that your devices that you want to build into your solution have been tested, work with AWS, the catalog is a great place to find these devices. And the device makers like to be able to say, yes, my device, my product has been qualified and it's in the catalog, and that means we have confirmed that it does work with AWS services. Here's just a screenshot I captured of the device catalog, and you can see you can filter that. Filter that over on the left side there and pick out the kinds of devices that you're looking for. And there's lots of devices in that. So let me just go ahead and stop there, and I'll go ahead and give back to Ed so you can continue on with the demo, Ed.
Thanks, Paul. All right, let me see if I can get my screen going here. All right, so I mentioned this ARM Total Solutions keyword application that I'm gonna walk through real quick. Here's the GitHub repository for it. It's got basically a lot of software to help you get up and running. So this is the software stack mostly that runs on the device, which in our case is going to be this virtual hardware device. But it also provides some scripts and things to help you get running pretty quickly. So, the README here has all of the instructions to do what I'm going to do. So I'm going to skip some of these steps along the way, but it gives you a little overview of the application that I talked about, including this Blinky application. Talks about how to get the AMI up and running on an EC2 instance. It'll walk through launching that on the local terminal. I'm sure many of you are already familiar with getting access onto an EC2 instance. It's going to talk about getting the code, basically cloning the code, building it using some scripts to get all the necessary tools needed, most of which are already on there, but there's a few special things that it needs to download. And then once you get something up and running, you can do things like change the audio file. I think the test.wav file that's in there today has a few simple commands. I want to say, I think yes, no, on, off, or I forget. We'll see when I run the demo what they are, but you can change that file and run your own tests through it. There's a section in here that tells you how to get this integrated with a continuous integration flow. Using GitHub runners. So that's an interesting thing that you wouldn't normally be able to do with an IoT device very easily. So you can have this straight in your code. So whenever you get a check-in, it'll automatically go kick off and build and run your application on one of these virtual hardware devices. There's a section in here about setting up AWS connectivity. So I'll show you that in the demo. And then there's, as Paul mentioned, over-the-air update. You can also use the AWS over-the-air update mechanism to update the code on the virtual hardware. So obviously you can just change the code in the EC2 instance directly and rebuild it, but you can test the over-the-air flow using this virtual hardware, which is something that's can often be very challenging, especially when you distribute it to a fleet of devices. So you could imagine, in this case, you could simulate a fleet of devices by launching a number of EC2 instances that represent actual hardware, and deliver an over-the-air update to all of them simultaneously, and test that flow before you actually do it to the field. So I think that's an interesting application for this as well. I'm not going to walk through that for this demo. But all the instructions are here to play around with this stuff. And I think there's a section in here on how to change the machine learning model. That's a little bit more complicated. And then an overview of the code that we talked about a bit. There's the machine learning model replacement. So lots of stuff in here. How you get started. So you're going to log on to your AWS console. You're going to get your EC2 instance running. The easiest way to do this in this particular case is to go into the AMIs. You're going to want to select the public images, and you're going to search for ARM virtual hardware with no spaces, and that's the name of the AMI. You can select this AMI. You can basically go straight to launching it. In my case, I'm using a C5 large instance, but I think we recommend at least a T3 medium. But there's a range of there's a range of EC2 instances that you can use for this. And basically, since this is simulation, the more powerful the instance, the faster your simulations are going to run. And we'll see when we're running it on this instance that there's some feedback on how fast the simulations are working. So I'm not going to go through the rest of these steps since I already have an EC2 instance set up and running. So here's the EC2 instance that I have. I got my public IP address. So I'm now going to SSH into this. This is where you would then clone the repository, which I've already done here. You can see ATS keyword. So let's go into there. And yeah, so this is the repo that we just looked at. And so we've got some scripts here that help you more easily run the application. And when I launched this, I launched it with some port mapping. So this AMI already has VNC. So if you want to get a remote desktop, you can do so. For the most part, you don't really need to, but I'm going to show you something with that because I think it's also pretty interesting. I'll show you the Blinky example. So I'm just using, I think just about any VNC viewer should work okay. Always good to password protect everything. Don't want everybody connecting into here. Yeah, so now I'm in the virtual machine. So again, seeing the same thing that I was seeing on the other terminal. Can go into the ATS keyword demo again. So we see the same thing here. One thing I want to remember to do though is the display for this, since it's a virtual machine, I want to set the appropriate display 1 so that it'll actually use this virtual terminal, this VNC session to display all my content. So to run this demo, we've got some scripts provided. So you can, the script will let you, set up the demo, download or build the code, which I've already done on here, and then you can run and choose which demo you want to run. In this case, I'm going to just show you Blinky real quick. And again, all this does is blinks an LED on the board. So the reason I brought up the VNC session is we actually have a virtual board here. And you can see there's a bank of LEDs at the top that are represented in this board, and they're flashing on and off, correlating to the LED on, LED off messages over here. This virtual board has the ability to have a debug terminal built into it. There's an LCD touchscreen. If there's time, I can show something showing on there. But this demo, all it does is flashes the LEDs, but you can see them here. There's also switches here that you could also build into your application, so you can turn switches on and off. So it's quite like a real board environment, except it's all just running up in the cloud. And then you see when I stopped the simulation, it's giving me some feedback on how much time it actually ran, what the wall time was. So I was just running that for 50 seconds. It implemented a lot of instructions, executed a lot of instructions in that time, and it's running at about 65 million instructions per second. So, you know, this simulation of this Cortex M55 processor, you know, is running something in the neighborhood of 65 megahertz, which is about what a real board would do in kind of the baseline IoT solutions. So that's pretty interesting. If you used a slower instance, EC2 instance, it would run a little bit slower, and then obviously faster could run a bit faster. I am going to switch back to the terminal for a moment here, just so we can see some things at the same time. And now what I want to do is I want to run the keyword spotting demo. And when I run the keyword spotting demo, I mentioned the, sorry, I've got my Zoom window is blocking my top of my browser here. So let me just shift this around a second. Okay. So in the AWS console, there's this concept of in the IoT grouping of services, there's this concept of a thing. And so, you know, Paul talked about the security. There's credentials and things that you need to set up and policies for what your thing's allowed to access in the AWS cloud. And you need to download some credentials onto the board, which I've already done and built into the application. But once you have your thing, you can actually start to, in my case, I've just got ARM virtual hardware thing, AVH thing. That's the name of the one that I created so far. And you can manage these things, and then you can do things like interact with them and see what sort of activity they've got going on. And so I just wanted to, well, let's go ahead and run the demo once first. So similar to what I showed you before, we would run this script, run, and KWS is the name of this demo. So this is actually connecting to the AWS IoT server. So it's making TCP connections. There's FreeRTOS connect. It's come to establish the connection, sending some MQTT messages back and forth. And then we're starting to get into the actual, now that it's done the basics setup, it'll start running the voice application. So it heard the command on. Sends an MQTT message. So while that's running in the background, I'm going to go back down here. Sorry, some of my window is blocked again. So this MQTT test will let you subscribe to MQTT topics. So anything that's being sent, this is a pub sub type system. I need to choose the right topic. So in my case, it's AVH thing, and then we created a topic in the code called ML inference, so I can subscribe. To that. So let me go back here and start this demo one more time, because I think we've already passed all of the messages. It's reestablishing the connection. Oops, forgot one thing to do here. We want to display these payloads as strings. Yeah, unfortunately, I did that in the wrong order, but we're seeing that messages are coming out here. There we go. Now we're seeing the message go. So that was the last thing that it heard. And then beyond that, we've just got some noise on the system. So we're going to occasionally get some unknown inferences. And then if there's no sound at all, then it detects silence. So you can see that this device now that's running in the cloud as a virtual device, running Amazon FreeRTOS and a lot of the libraries that Paul was showing earlier, is executing, connecting up to the AWS cloud, sending messages to the IoT core. And you can imagine at that point, from an IoT device standpoint, you've got most everything that you would have in a real system. So, and then again, when you stop the simulation, it gives you some idea on the performance of things. We also have some information on profiling and getting performance numbers on the machine learning portion of it that's running on the accelerator that we have in there. So there's a lot of interesting information that you can get during the development process. So that's pretty much all I had to show for the demo. Just a couple last slides, and then we'll be wrapped up here. So let me get my slides back on here. So yep, that was the demo. And then pretty much here's the resources. I think we'll provide these to Rayon, and he'll be able to add those to the recording for this. So you'll have some links that you can click, but there's an overview of ARM virtual hardware. There's the documentation about it. There's some developer resources that give you a lot more of the details of how you can write those Python interfaces for virtual IO and all that kind of stuff. And then there's the GitHub repository for the example that I just ran through. And then in addition to the drawing that you're going to have today, if you are interested in using ARM virtual hardware and you sign up through this link here at ARM, you also have the opportunity to qualify for some credits for an EC2 instance to run ARM virtual hardware. So currently ARM virtual hardware is completely free. You're just paying for your EC2 instance time. And yeah, if you get these credits, then we'll be able to offset that as well. And that's it.
Okay, thanks, Paul. Thanks, Ed and Paul. That was really insightful. It's actually amazing to see like how far we've come to be able to simulate your hardware in the cloud and then communicate everything in the cloud. And it's actually very convenient. It makes it very easy, I think, for all of this IoT type of development. I think let's go into the Q&A. If anybody has a question, please unmute yourself and ask it, or pop it there in the chat. While we do that, please fill out that survey but I sent that bit.ly one. Let me just send that again, and that's your entry to the into the lucky draw, where I'll give away some AWS credits. We'll do the draw here live. We'll spin a wheel. So questions, anyone? I have a few. If nobody wants, nobody has. No.
I'll just make a quick
Okay.
comment. As with the credits, and if you use the starting and stopping of EC2 instances when you're not using it, your credits go a long way. So you can experiment with these, test these things out, and just stop your instance when you're done with experimenting around with things, and start it back up later if you want to try something else. But starting and stopping those instances can save you money and makes your credits go a whole lot farther.
Sure does. Paul, so while I have you here, I just had a question about that secure element that you showed there. So that's a physical chip that sits next to the ARM processor, right?
Typically, that's right. Yeah, it'll typically be soldered onto the board next to your microcontroller. But well, not always, but typically that's how it would be. And it gives you, though, it's a secure storage. So you can put your certificates, your private keys, things like that in there, and know that they're not, if you put them in your code and they're stored, on the flash, that, if the device is physically accessible, it can be tampered with, and those can be, taken from you. But the secure elements improve that. Ed, if you wanted to add more to that, you're the hardware guy, not me.
Yeah. I mean, that pretty much covers that for the most part, I think. I know for some of the lower cost applications, the secure elements can definitely add to the bill of materials. Some of the later ARM processors, the version 8 architecture for our Cortex-M processors have something in them also called Trust Zone. And this M55 is in that category. It's got Trust Zone built into there as well. And what Trust Zone allows you to do is set up a secure side boot process and partition your memory so that only the secure side can access certain parts of your flash, certain parts of your SRAM, and then use that essentially as an onboard trusted execution environment to replace that external part that you would need for a low cost solution. And obviously it doesn't provide the exact same level of security, but it provides quite a bit of security as well. And this example already has all of that built into it. The Trust Zone is in there. We've got something called trusted firmware. I didn't go through the details, but there's actually a secure piece of code that boots called trusted firmware, sets up, reads the credentials, has them in the appropriate storage. And then when the application is running and it needs to do something like send an encrypted message, then similar to what it would do with the external part, it would send a message over to the secure side and get the packet decrypted or whatever it needs to do, signed, verified, and so on. So it's an interesting low cost replacement for that kind of solution for your really low cost IoT devices.
Okay, so basically you don't need that secure element to be able to speak with AWS IoT. You can store that on the flash itself if you really wanted to. Yeah,
that's correct. And and again, the secure element has somewhat higher level of physical tamper resistance and things like that, but the Trust Zone architecture provides a good bit of security. And this all follows another thing that ARM's been involved with called the Platform Security Architecture and PSA certified, which is basically a certification body saying that you've met this SoC or this board or this device meets some level of security that includes boot, it includes secure and storing credentials and establishing secure internet connections and so on. So that's another thing that we participate in to make sure that we're raising the bar of security. There are a lot of there are a lot of IoT devices out there where the credentials are not protected like they should be, and that's why we see a lot of these IoT hacks and these IoT basically bot networks that are doing denial of service attacks from your home IoT devices or something like that. So the security part of it is definitely becoming a more and more serious matter.
I see somebody raised a hand. Asia, is it, or was it you? You maybe want to unmute yourself and ask your question.
Hello, okay. Thank you for the opportunity. Yeah, I just want to ask about the IoT. I want to ask about, is there any certification for IoT? And number two is the learning path. Let's say if I want to start the career in IoT, what do you recommend me where to start? And then the last question is about the sandbox. Do you have a platform, a free platform where I can practice my project for IoT? Yeah, thank you.
Paul, do you maybe want to
I'm not sure I understood the first part of the question. Was that certification? Are you talking about training material that's available, or certification for IoT skills? Is that what your question is?
Yeah, certification for IoT, to be certified, like to be an IoT specialist.
Well, they have solution architect certifications, but they also have ML certifications, but there's not an IoT specialist certification at this time.
Yes. So I think you'd probably need some kind of hardware type of background, and you'll probably not get that from the AWS side. So you're probably looking at some kind of course here in South Africa, maybe through UNISA. That's actually where I got my electronic communication diploma. So it's definitely possible. And then for the IoT type of side, you would probably then look at some cloud certification and start upskilling and training in that as well. And I think once you have both of those type of skill sets, you'll really be in a very good space to do IoT, both hardware and software. I also don't know if you would really specialize in one path or the other. You'd probably not do both, because people that build these projects, there's usually big teams, and then there's teams that focus more on the software and some more on the hardware. But I'm also not an expert in this field.
Let me offer one more piece just to add on to that. The team that I work in, we are actually building some training materials, and we are going to be making those freely available. So although it's not a certification program yet, it will provide you a lot of there are going to be a lot of freely available IoT training materials available if you just check the websites and watch for notifications, and there might be some announcements about that next week too. So watch for those.
Yeah, and on the hardware side, ARM is a pretty good resource for starting to come up to speed on IoT development. If you look at the developer.arm.com website, there's a lot of information there about how to get started on ARM platforms, including this demo that I just walked through now. And then in terms of a sandbox on where to get started, I mean, today to get started in embedded software, you need to go out and buy a board and kind of do all these things on your local development platform. So I think the idea now is to take advantage of this ARM virtual hardware. As I said, the virtual hardware is free. But the EC2 instances, I don't think the free tier EC2 is quite enough to run this application. But we do have that opportunity to sign up for some credits to offset your usage for running the virtual hardware to get you started.